Hi guys, and welcome to your video for 3.1.4, which is how I can use equivalent ratios. So we're actually going to be applying or working with the applications of ratios and working with the notation of it. So when you guys come into class, you guys are going to be working on 3-15 and another little activity I have planned for you. We're going to do 3-16 and 3-17 together in the video, so make sure you write those down in your notes. And then 3-18 and 19 you guys are going to do on your own, and then you guys have an exit ticket. So, like always, to start off the video, I have a little joke for you. And it says, why shouldn't you write with a broken pencil? Because it's pointless. Alrighty. So if you remember what we've been working on before is we started this idea about similarity. And if you remember, similarity means that some parts have to be the same, but not all the parts. So when I mean that is all of the angle measures have to be the same. Okay, so something similar, they're going to have the same angle measures. Likewise, they have to have the same ratio between all of the sides. So if you have 4 and 8, you can't have 2 and 6 as the other sides because one's going by 2, one's going by 3. So it doesn't work. You have to have the same ratio. So that's the difference between similar, and then if you think about congruent, everything has to be the same. So we'll learn the notation for similar, and we'll dive more into that today. So today I want to start off by going through a couple questions for section 3.1.4. Looking at 3-16 here. We are talking about just the connotation and the notation behind it. So when we're working with geometric shapes, such as the similar triangle below, it is easier to explain which sides are comparing by using notation that everyone understands. So one of the possible proportional equations for this triangle is BC. So we're working with BC, and EF is equal to AB over DE. So you want to make sure that you're setting up your proportions correctly and all that fun stuff. And it says write at least 3 more proportion equations based on the similar triangles above. So we could write AC over DF is equal to AB over DE. We could write AB over DE is equal to, no, we'll go back to AC. AC over DF is equal to BC over EF, and so on and so forth. So you're just matching up the right sides with the correct proportion. So that one's pretty self-explanatory. Then Jeb noticed that angle A is equal to angle D, angle C is equal to angle F, but what about angle B and E? Do these angles have the same measure? Or is there not enough information to justify your conclusion? So if you think about it, to get angle B, we would take angle A plus angle C, which would give us some number. We would take that number, we would subtract it from 180 to get angle B. We would take the same exact process for the triangle above. So you'd say angle D plus angle F is equal to some number, and you're going to take 180 minus some number is equal to angle E. Since A is equal to D and C is equal to F, that means angle B has to be congruent to angle E, because you can interchange those. So since it's an equal sign, I could say angle D plus angle F is equal to and take that from 180 is equal to angle B. So you're just using the angle triangle summing theorem. We've already talked about this topic to prove why those angles have to be congruent then. Alrighty. 37. These two triangles below are similar. Read the math note box from this lesson to learn about how to write statements that show two shapes are similar. So that's what we are going to go to. So here's the methods of meaning math note box. So writing a similar statement. A similarity transformation is a sequence of transformations that can include rigid transformations, dilations, or both. Two figures are similar if there is a similarity transformation that takes one shape into the other. Similarity transformations preserve angles, parallelism, you get the point, of two lines and ratios of side lengths. To represent the fact that two shapes are similar, use the symbol, and it's not written there, I don't know why, but your symbol is that. So that represents that two things are triangle. For example, if there's a similar transformation that takes place between ABC and DEF, then you know that they are similar. And this can be stated as triangle ABC is similar to triangle DEF. So this is similar. And then this is congruent. Just so you remember. Okay, so congruent's got that equal sign in it, so that's how you can remember that. Okay, congruent means that they're equal. Similar is just got the squiggly line. So the way that I think about it, it's kind of like an equal sign. Like it's the top line of an equal sign, but it's bent because it's not exactly equal. Alrighty? Okay. Then examine the two triangles below. Describe a sequence of transformations that carries one triangle into the other using tracing paper to help. So the first thing that I saw was maybe I could draw a line like right here. And I see that it is reflected over that line. And then after it's reflected over that line, it's dilated. So it's made bigger, obviously. The thing that the book says is it's reflected over, or reflect triangle DOG across the line OG, which would be this guy right here. So you're reflecting it across that. Then translate it so that point D lies on point C. And then dilate it. So it's the same idea. They're just using the shapes instead of this black line. I thought it was easier to use just an imaginary black line, which is the same thing. You're reflecting over a line, and then you're blowing it up from there. Which of the following statements are correctly written and which are not? Note more than one statement can be correct. Discuss your answers with your team. So just to review, and things are going to get more complicated. You're sitting here saying like, are we really going to sit here and state which of these statements are similar? We're going to go through it. But the reason that we're watering it down so much is that it's going to become more complicated, and you're going to have to be able to rotate these things and translate these things in your head to be able to see which parts line up. So the thing that I like to do is I like to set angles equal to each other or similar to each other. So I know that C is equal to D. I know that G is equal to A. And I know that O is equal to T. So if I'm looking through one of these and I notice that, okay, so I have D first, which means I should have C first. Good. I have O next, which means I should have T. Nope, gone. So that just makes it easier for me. I know that, hey, if I've got my angle measures lining up, there's no way I can mess these up. So we move to the next one. I got D and I've got C first. Good. I have O, so I should have T second. Good. And then I have G and I have A next. So that one works. I have O first and A first. Nope, gone. And then I have D and C. Good. G and A, we're good. And O and T, so we're good. So those are the two that are congruent. So that's just going through similar figures and the connotation and working with the ratios and working with the actual symbol of similar. So the very last thing I want to do is I'm going to go through the review preview problems. So the first one says that Frank and Alice are penguins. At birth, Frank's beak was 1.95 inches long, while Alice's was 1.5 inches long. Frank's beak grows by 0.25 inches per year, and Alice's grows by 0.4 inches per year. Write an equation that represents the length of each penguin's beak in X years. So I'm going to make each of them equal to Y. And I'm going to say Frank's beak was 1.9. Actually, let's do the years first. So every year it grows by 0.25. So if I want to know how much it grew within the second year, I'm going to multiply that number by 2. But we can't forget that when he was born, it was 1.95 inches, which would be my y-intercept. Similarly, I'm going to write an equation for Alice's beak. And again, I can't forget that my y-intercept is always at the end. So right there, and then this is just a system of equations, so I'm going to set 0.25x plus 1.95 equal to 0.40x plus 1.50. And then I'm going to go ahead and solve for this. So I'm going to subtract 1.50. So I'll have 45 here. And then I'm going to subtract 0.25x, 0.25x. And I'm going to get 15x, 0.15. And then my very last step is to divide by 0.15, and I will get 3 years. So x is going to equal 3. So in 3 years, they will be the exact same length. So that was just a system of equations in another format in a word problem for you. Alrighty. Plot A, B, C, D, E formed with these points onto the graph paper to save some time. I already did that for us. Use the method from problem 3-2 to enlarge the original by a factor of 2. Label the new one to find the shape. Not quite sure. There we go. So I'll do my enlarged figure in red. So remember, anything that I'm enlarging, I'm going to go ahead and multiply by 2. So my point A is going to be -6, -4. And that didn't change at all. Oh, there we go. My new B is going to be 10, -4. So I'm just going to pretend. C is going to be 10, 6. D is going to be 12, 2. I'm sorry, 2, 12. And then E is going to be -6, or +6. So there's our new house figure. Find the area and perimeter of both figures. So the first thing I did for this guy to find the area and the perimeter is I broke this up. So I broke this up. So one was a rectangle right here. And then I had the triangle up top. So the rectangle was 5 by 8, which would make this 40 for the area. And then 1/2 base times height tells me 1, 2, 3, 4, 5, 6, 7, 8. 8 times 1/2 is 4. 4 times 3 is 12. So add those together. And for my area, I get 52. And then for my perimeter, I've got 1, 2, 3, 4, 5, 8, 5. And then up here, what you can do is you can do the Pythagorean theorem. You can break that in half and figure out one of these lengths, and you know it has to be that same length. So I've got a 4, I've got 3, 3, 4, 5 triangles. So I know this is 5 based on patterns. Is something I'm going to show you guys later on. But if you ever have a right triangle with legs of 3 and 4, you know that the hypotenuse is always going to be 5. So I have 28 as my perimeter. So Those are my area and perimeter. And then for area in an enlarged figure, I know that I'm going to be multiplying it by 4. So I can go ahead and say that that's going to be 208 without even doing any math. And then my perimeter is just going to double. So my perimeter is going to be 56. So not even any math there. You just know the patterns. You know the dilations. That's what happens. And you're done. So that's all I have for you guys today. Make sure that we come ready to work tomorrow because we got a lot to cover in tomorrow's class. But I have a little surprise for you guys, so I hope that it's fun. And I will see you guys tomorrow. Have a great night.